Hey everyone, this video we're going to check out section 7.4. We're going to do a little bit more on graphing linear equations. So specifically, we're going to talk about horizontal and vertical lines. And we're going to talk about graphing linear equations using their intercepts. Use slope-intercept form to graph a line, which is something that can give a lot of people trouble, as well as talking about horizontal and vertical lines, which gives people trouble. And lastly, talk about parallel and perpendicular lines. So this is a rather meaty section. Intercepts. We talked about the intercepts before. The y-intercept of a line is the point 0b, here in blue, where the line crosses the y or vertical axis. The x-intercept is the point A0. It's where it crosses the horizontal axis, or the x-axis, and you can see that intercept in red. We can use the intercepts to graph a line. So for this line, what I'm going to do is I'm going to go ahead and say, what if x is equal to 0? Then I would have 0 minus 6y is equal to 24. I would have y is equal to negative 4. So that would be the point 0, negative 4. X is 0, y is negative 4, right there. Okay, so now what if I had y is equal to 0? Then I would have 3x minus 0 is equal to 24. Divide by 3 gets us x is equal to 8. So that's the point 8, 0. 8, 0 is right there. Great. We can connect those with a line. Almost. I'll just rewrite that. X is equal to 8 is the point 8, 0. And connect those with a line. And that's our line. X is equal to 0. Y is 0, negative 4. So there's negative 4 right there. Y is equal to 0. X is 8. 8, 0. There's that point. And then we connect them with a line. Ta-da! What if we have the line y is equal to 2/3 x minus 1? Well, b equals negative 1, so the y-intercept is negative 1. I'm going to plot that. Then this slope is 2/3, so I'm going to go to the right 3, 1, 2, 3, and then I'm going to go up 2. Why it does that? Negative 1, 1, 2, 3, and then up 2, 1, 2. Here's my other point, and I connect those with a line. And that is my line. That's my graph. So we find that point to start. The bottom is 3, so we count right 3 units. Badoop. The top is 2, so we count up 2 units. Badoop. We're going to make a mark there. That's the other point on the line. We now have 2 points. Let's connect them to finish our graph. Badoop. And that's how that's done. Let's use this method to graph 5y plus 2x equals 0. We'll start by saying I want x equal to 0. Then we'll have 5y equals 10. We'll have y equals 2. So 0, 2. If y is equal to 0, then we have 2x is equal to 10. So we have x equals 5, 5, 0. Connect them. We've got our line. What if we did it the other way? We'd have 5y plus 2x is equal to 10. 5y is equal to minus 2x plus 10. Y is equal to negative 2/5 x plus 2. So we start at 0, 2. We go to the right 5, 1, 2, 3, 4, 5. And then negative means we go down 2, 1, 2. There's our next point. It's the same line. Cool, cool, cool. Start at 0, 2. Go to the right 5, go down 2. Connect them. That's our line. Great. Lines of the form y equals b are horizontal. They are said to have slope m equals 0. To graph them, draw a horizontal line at the height indicated, height b. Let's graph y equals 3. 3 is it? Done. Lines of the form x equals a are vertical lines. They have undefined slope. Undefined. To graph them, draw a vertical line through width a. Let's graph x equals negative 2. Aha, negative 2 you say? There's negative 2. Vertical line. Oh my goodness. Vertical wave. Oh, thank you for fixing my mistake, computer. Now, if I'm going to graph two lines, they could either be the same line, they could intersect once, or they could not intersect at all. And not intersecting at all, this is all Euclidean geometry would allow. And not intersecting at all right here, these two lines, 3, 3, they're parallel. So we graph the lines y equals 2x plus 1 and y equals 2x minus 4. These lines have the same slope, but they've got different y-intercepts. They're never going to cross. They are parallel lines. So to determine whether or not lines are parallel, you put them into slope-intercept form. 3x minus y equals negative 9. Get the 3 over, or get the 3x over. Minus y is equal to negative 3x minus 9. Change every sign. Y is equal to 3x plus 9. My slope is 3, my y-intercept is 9. Let's do the same thing with this equation. I'm going to add 6x to both sides. We'll get 2y is equal to 6x minus 2. We're going to divide everything by 2 to get y is equal to 3x minus 1. So m here is 3 and my intercept is negative 1. M is 3, m is 3. They've got the same slope. They are parallel. The other interesting thing we could have is a perpendicular line. They cross once, but they're going to meet at a right angle. So anytime we have two lines meeting at a right angle, they are perpendicular. This first one, the red one, has a slope of 2, and the blue one has a slope of negative 1/2. That sort of inverse perpendicular slope is the negative reciprocal. Two lines are perpendicular if the product of their slopes is negative 1. That is, if one slope is the negative reciprocal of the other slope. The product of slope 1 and slope 2 is negative 1, or slope 1 is equal to a negative 1 divided by slope 2. Since vertical lines don't have slope, we also have to make special mention that a vertical line and a horizontal line are also perpendicular. We can get lines in the slope-intercept form to see if they are perpendicular. 2x minus 5y is equal to a negative 3. We subtract the x over and we get negative 5y is equal to negative 2x minus 3. Divide everything by negative 5 to get y is equal to 2/5 x plus 3/5. 5x plus 2y equals 6. We're going to start by subtracting 5x, and we'll get 2y is equal to negative 5x plus 6. We divide everything by 2, and we get y is equal to negative 5/2 x plus 3. So this second slope is negative 5 halves. We can see that their product is a negative 1, so they are perpendicular. That's it for this section. Next section, we'll do some more with the equations. Thanks so much.